Welcome dear students, we are on the CEC-UGC lecture. We are in the series of the electronic circuit and we are discussing the various components used in the electronic circuit. And today's topic is related to the OLED, that is the Organic Light-emitting Diode, which are generally used in the display devices like mobile phones, like LEDs, like we can say that in the various form, like we can use it in the desktop, computer desktop. So what is the construction, what is the structure of the OLED cell? How we prepare this OLED. Basically, OLED consists of a stack of thin organic layers sandwiched between the conductive anode and the conductive cathode. So, and what is inside its structure? So, we are having a cathode, we are having a anode. First, the important thing in the OLED structure is the substrate. That can be substrate can be plastic, can be of the plastic, glass or the metal foil. That is the foundation of the OLED. So substrate is very important part in the OLED on which we develop the OLED. So first is the substrate in the structure of the OLED, which is of the plastic, glass or the any metal foil. Next important part is the anode, which may or may not be transparent depending upon the type of OLED. Positively charged to inject holes means there is the absence of the electrons into the organic layer that makes up the OLED device. The next point is the hole injection layer, and the hole transport layer is also the part of this anode. Then hole injection layer, that is deposited on the top of the anode, and this layer receives the holes from the anode and injects them deeper into the devices, and it go into the transport layer. Next is the hole transport layer, and this layer supports the transport of the holes across and it so they can reach the emissive layer. Now this emissive layer, what is this emissive layer? This is basically the heart of the devices where the light is made. The emissive layer consists of a color defining emitter doped into a host, and this is the layer where the electrical energy is directly converted into the light and we get the output. Another important layer is the blocking layer. Basically, this is used to improve the OLED technology by confining electrons charge carriers to the emissive layer, and it can block the extra charge carriers. Next is the electron transport layer, that is near to the cathode, and this support the transport of the electrons across it, and so they can reach the emissive layer. Next is the cathode, and it may or may not be the transparent. It depends upon the type of OLED which we are using. Basically, what this is cathode, this is the negatively charged to inject electrons into the organic layers that make up the OLED device. You see on the screen that this is the structure of the OLED, where on the top we are having a cathode, at the bottom we are having a substrate, and on it there is a anode. In between that we are having a various layers. The upper layer is the electron transport layer, which is near to the cathode, and lower level above the anode is the hole injection layer. Above the hole injection layer, that is the hole transport layer, and above it there is a emissive layer, that where we can get that where the light is emitted from this emissive layer, and above it there is a blocking layer which block the movement of the electron inside a emissive layer. So this is the basic structure of the OLED, which consists of cathode, anode on the substrate, and in between that we are having the various organic layers. To generate the red, green or blue light to the render full color images, there are two main approaches currently being used. The first is we use the pattern red, green and the blue OLED pixels in each pixels of the display. And this is generally preferred approach of the high resolution mobile display. Now OLED, how we classify the OLED? We can classify the OLED in many ways, on the basis of the device structure, on the basis of the material we are using, on the basis of the output, we can define the OLED. So OLED is classified by the device structure. We can discuss it here. So on the basis of device structure, we define it in the many form like single layer device, double layer device, 3-layer device, and the multi-layer devices. OLED is a kind of organic electroluminescence device which is composed of relatively special organic materials. According to its structure, it can be divided into 4 types. Number 1 is the single layer device, second is the double layer device, third is the 3-layer devices, and 4 is the multi-layer devices. In the single layer devices, is to insert a layer of organic layer that can emit light between the anode and cathode of the devices, and its structure is substrate, IOT, light emitting layer, and the cathode. It means here we are having only the one layer, and this structure, due to the imbalance of the electron and hole injection and transport, the efficiency and brightness of the devices are low and the stability of the device is poor. So single layer, where we are using only the one layer of the organic material. Double layer devices are based on the single layer devices. Hole transport layers or the electron transport layer are added on both the side of the light emitting layers to overcome the problems of the unbalanced carrier injection in the single layer devices. And because of this, the device efficiency performance improved, and the voltage current characteristics of the device improve the luminous efficiency of the device. So in the double layer devices, there we add the 2 layers, that is the hole transport layer and the electron transport layer. The third type of device is the 3-layer devices, where this device structure mostly used and this structure use the substrate, IOT, HTL, light emitting layer, and ETL and cathode. And the advantage of this structure is that the excitons are confined in the light emitting layer. In this we are having a light emitting layer in this type of 3-layer, thereby increasing the efficiency of the devices. Last but the important is the multi-layer structure, and it is a better structure which can play the role of all the levels. The light emitting layer can also be composed of the multi-layer structure, and generate the layers are independent of each other and then can be optimized separately, in which we can add or remove the layers. Therefore, this structure can give the full pay of the role of each organic layer, which greatly improves the flexibility of the device design. If we classify the OLED by the driving method, the OLED are generally divided into 2 types. First is the active type and second is the passive type. The active type is generally an active device and the passive type is the passive device. In actual application processes, active drivers are mainly used for the high resolution products, while the passive drivers can mainly used for displays and relatively small display sizes. So if we use the high resolution, then we use the active drivers. If we use the display with familiar displays and small sizes display, then we use the passive drivers. If we classify on the basis of the material, so the material makeup OLEDs are mainly organic, that we know, and which can be classified according to the type of the organics. One is small molecule and other is the polymer. So the main difference between the 2 devices is the manufacturing process. The small molecule devices mainly uses the vacuum thermal evaporation process, and the polymer devices use the spin coating or the spray printing processes. So on the basis of the material, we can classify the OLED into the two forms. First is small molecular and another are the polymers. What are the types of the OLED? If we talk about the passive and active matrix, so there are the various types of the OLEDs. Number one is the passive matrix OLEDs. Second is the active matrix OLED. Third is the transparent OLED. Fourth is the top emitting OLED. Fifth is the foldable OLED. And sixth is the white OLED. Moreover, most of the OLED are designed according to its application. Nowadays, nano OLEDs are also because we are using the nano materials in development of the OLED. Each type has a different uses, and the following section we will discuss each type of OLEDs. Let us start with the passive matrix and the active matrix OLED. As you screen, this is the basic structure of the OLED. Now, what is a passive matrix OLED? That is also called PMOLED. This PMOLED have strips of the cathode, organic layers, and the strips of the anode. Here we are having a 3-layer cathode, organic layer, and the anode. The anode strip are arranged perpendicular to the cathode strip. The intersection of the cathode and anode make up the pixel where the light is emitted. We can see it here. So that where the light is emitted, external circuitry applies current to the selected strips of the anode and cathode, and then determining which pixel get turned on, which pixel remains off, then the light will be generated. Again, the brightness of each pixel is proportional to the amount of current we are applying. So, PMOLED are easy to make, but they consume more power than the other type of OLED, mainly due to the power needed for the external circuitry. So, PMOLED are most efficient for the text and icons and are best suited for the small screens, such as those you can find in the cell phones, PDAs and MP3 players. Even with the external circuitry, passive matrix OLEDs consume less battery power than the LCDs that currently power these devices. Passive matrix devices have anode strips that are arranged perpendicular to the cathode strips, and this specific intersection make up the pixel that emit the light. You see here on the screen that here the cathode and anodes are arranged in a mesh type of structure, and it is on the organic layer. These are perpendicular to each other. Now, the brightness of each pixel is proportional to the amount of the current applied. However, the external circuitry is needed to apply the current to the selected strips of the anode and cathodes, and in this manner this light generates. Next type of OLED is the active matrix. Here, active matrix OLED have the full layers of cathode, organic molecules, and the anode. There is no strips type of structure, but here we are having the full layer. But the anode layer overlays a thin film transistor, that is a TFT, and array that forms the matrix. The TFT array itself is the circuitry that determines which pixels get turned onto the form on an image. You see on the screen that there is a active matrix OLEDs, and these AMOLEDs consume less power than the PMOLEDs because the TFT array requires less power than the external circuitry. So, they are efficient for the larger display. AMOLED active matrix OLEDs have faster refresh rate suitable for the videos. So the best uses of AMOLEDs are the computer, monitors, large screen TVs, and electronic sign and billboards. Next type of OLED is the transparent. As the name suggests that the transparent components are used, substrate, cathode and anode. And when turned off, are up the 85% are transparent as their substrate. When the transparent OLED display is turned on, it allows light to pass in both the direction. A transparent OLED display can be either active or the passive matrix. This technology can be used for heads-up display. As you on the screen, this is the transparent structure, like where we are having all the anode, cathode and combination layer. And here the light can be formed on both the sides. This is you see the live example of the OLED. This is the transparent OLED. Next is the top emitting OLED. Name suggests as it is the substrate that either opaque or the reflective. So they are the best suited to the active matrix design. Manufacturers may use the top emitting OLED displays in the smart cards. You see here, this is the form of the top emitting structure. You see the light is output, we can get off from the top only. This is the top emitting structure. Foldable LED, name suggests that it is a flexible metallic foil. We can fold this type of OLEDs. So foldable OLED have substrates made of the very flexible metallic foils, or it is made of the plastics or PMT paper. Like foldable OLEDs are very lightweight and durable. They are used in devices such as a cell phone, and PDAs can reduce breakage, major cause return or repair. Potentially foldable OLEDs display can be attached to fabrics to create the smart clothing, such as outdoor survival clothing and integrated computer chips, cell phones, CPS receiver, OLED displays. When we can use this foldable, you see on the screen that this is one type of the flexible OLED that can be adjusted according to the flexibility. Next is the white OLED that emit the white light is the white OLED, and that is a brighter, more uniform and more energy efficient than that of the emitted by the fluorescent light. White OLEDs also have the true color qualities of incandescent lighting. Because OLED can be made in the large sheets, they can be replaced fluorescent light that are currently used in the homes and the buildings. The white OLEDs we generally use in the buildings, and their use could be potentially reduce the energy cost for the lighting. You see on the screen, this is the white OLED generally we use in our home and offices. Next, OLED, which is also the important, which is the polymer OLED, where we use the polymer for the construction of the OLED. OLED emissive material used in display are categorized into the two forms. First is the small molecule and second is the polymer group. The first discovered by the Cambridge University in 1990. The polymer refer to the material is the molecular weight over the 10,000 gram per mole. Polymers are heavier and more complex than the small molecules. So therefore, inkjet printer process using solvent instead of evaporation processes is more ideal for the polymer material. It means we are using the printing technology for the flexible development, for the flexible foldable. By using the polymer material, we can develop the OLED. Now you see, this is the process how we will we use the polymer for development of the OLED, where the inkjet printing process of the OLED we use, where we use the ink formulation, second is the deposition, third is the annealing. It means we prepare a OLED by using the printing technology in order to utilize the polymer material as OLED display pixels. They first needs to be formulated into the inkjet ink printer. For every red, green, blue light emitting material, it is rapidly soluble by the solvent and dissolved into the ink, and we print it on the polymer sheet. Once the ink is prepared, it is placed in the printer nozzle and deposited in the precise location for display the pixel formation, and ink is dried, cooled down and turned into a thin film pixel after annealing. And unlike the small molecule OLED that use the fine metal mask, polymer OLED offer the higher yields for material consumption and atmospheric pressure without a vacuum chamber, and we use the printing technology for development of it. What are the characteristics of the OLED? The reason why OLED technology can be widely used is that the following advantages and compared with the other. First is the low power consumption. Second is the faster response. Compared with the other technology, OLED technology has a fast response speed, and the response time can reach the microseconds level. The higher response speed achieves the better moving images. According to and the third one is the wide viewing angle compared with the other displays, because OLED is actively emitting light, so picture will not display distortion in the large viewing angle ranges. Next is the able to achieve high resolution displays. By using the high resolution OLED displays use the active matrix, and whose light emitting layers can absorb more colors and give the high resolution. Another is a wide temperature characteristics. Compared to the LCD, OLED can work in the large temperature range. According to the relevant technical analysis, the temperature can be operated from -40 degrees Celsius to the 80 degrees Celsius. Another important point is the OLED can realize soft screen, and nowadays we are having a foldable screen. Flexible substrate we use for development of the OLED. And the organic layer is vapor deposited or coated on the plastic substrate to realize a soft screen. Another important characteristic is the quality of the finishing OLED is relatively light. Compared with the other products, OLED has a smaller quality and smaller thickness than the LCD. So we use it there are the many application of the OLED in the commercial field. Small size screen we use because of the characteristics we use for the display devices, and it is having a high brightness, high view angle. So we use in the many electronic devices like TV, flat panel, digital cameras and other fields. And apart from this, in VR technology we use these OLEDs, and OLED screens are used in the LCDs. In the transport field we use LEDs, OLEDs, GPS, and in the medical field for the surgical screen monitoring, motor diagnosis we use the OLEDs. So these are some of the application of the OLEDs. Thank you very much.